So uh, basically we have different indicators that will change into different colors once added to a solution, to an acid-base solution. And so these indicators are used to indicate whether the solution is acidic or basic, and they're also used to indicate the range of the pH. So if you look at it, when a strong base and a strong acid add, they use bromothermal blue, which is gonna turn yellow when it's acidic, and it's gonna turn blue if the solution is basic. And phenol phenolphthalein is gonna change into colorless if it's acidic, and turn into pink if the reaction is basic. And bromox, man, I hate this name stuff. Bromox bromocerol bromoresol green is gonna change into yellow when it's in an acidic solution, and change into blue when it's in a basic solution. So the other thing to keep in mind is that these indicators work in given pH intervals. So if you have a solution, then you put one indicator in, it doesn't work, that means you should use another indicator because the pH is not in that within that range, sorry. So just keep that in mind. I don't think they're really gonna ask you that much about them, but so titration is a method that is used to determine the concentration of a substance by using another standard solution. So if you remember, a standard solution is a solution in which the concentration of the solute is known. So basically, by using titration, you're gonna have a solution where the concentration is not known, and you're gonna have a standard solution where the concentration is known. So you're gonna have to use the standard solution to determine the concentration of the other solution that you don't know. Basically, they're just gonna be, basically, you only need to memorize, like, I think for titration, this is the most important equation to memorize. And you need to also memorize the SI units of each, because most of the time they might give you the volume in cubic centimeters, in milliliters, in kiloliters. So you're gonna need to know that every time you see volume, it has to be in liters. That's why, like, here they say, make sure that all your units are correct in your calculations. So here, like it's an example of titration. I know, have you done titration before? Like, are you aware on how to use it, or can we go through this example? Because I think it's the harder part when it comes to acids and bases.
We can go to the example, so
So let me just try. Let me just try this. So here we have a solute. We have an equation, a chemical reaction. So they say 25 cubic centimeters of NaOH solution is pipetted to a colonel flask and titrated with 0.2 m of hydrochloric acid. Using a suitable indicator, it is found that 15 cubic centimeters of the acid was needed to neutralize the base. So now they want us to calculate the concentration of NaOH. So the first thing that we must always do when we see a chemical reaction, we must balance the equation. So in this particular case, everything is already balanced. So then the second thing is that you have to convert to the correct unit. As you can see here, they converted the volume from cubic centimeters to cubic decimeters. You can either do it like this. You can just divide 25 by 1,000. Or you can just say 25 times 10 to the exponent -3. So the next thing is that you have to calculate the number of moles, because when it comes to stoichiometry, you're always gonna operate using the number of moles. You don't use the mass, you don't use the concentration, you don't use the volume. When it comes to using ratios, you're gonna have to use the number of moles. So here, you know your concentration is equal to N over V. You get your number of moles of HCl that has been used. Then you're gonna check the ratio of HCl and NaOH. Here it's gonna be 1:1. So that means you don't have to change it that much. So now you have the volume of sodium hydroxide, and by finding the concentration of hydrochloric acid, which is in this particular case 0.003 mole, you just use the ratios, which is 1:1. So that means the number of moles of sodium hydroxide is equal to the number of moles of hydrochloric acid. Then now you have your number of moles. You need to find the concentration. They gave you the volume, so you just say C is equal to N over V. Then here you find the concentration. Do you understand it? Sorry. I'm sorry, do you understand it?
Yes, sir.
Okay. But basically, first thing first, convert to the right units, calculate the number of moles. Okay, sorry. First thing first, balance the equation, convert to the right units, calculate the number of moles, use the ratios, and you'll get your final answer. So I'm just gonna go the next question to the next top chapter. I think this is like the problem is that with this book, it's just full of a lot of experiments. So I'm not sure if we can do this, but do you mind like I don't know, can you screenshot question 2 for homework purposes? So maybe next time when we meet, you can just tell me whether you're able to do it or not. I think if you're able to answer this question, then you most likely understand the work because it's a simple question. It follows the exact same steps. So just take it down. Then did you write it down or did you screenshot it?
I'm gonna write it down now, sir.
Okay. Should I give you like 5 minutes to write it down, or do you want to answer it? Do you want to answer it now? So for the equation, they say we have a solution of sodium carbonate. So that's gonna be NaCO3 that is used to neutralize hydrochloric acid. It's gonna be HCl. So that's gonna be an ACl plus H2O plus CO2. So here we're gonna have 2, then here we're gonna have 2, here we're gonna have 2, 1, 1, 2 carbon. I think this is supposed to be 2 as well. Is this what you got? I'm sorry, is this the equation that you got? Sorry?
Yes, I did get that.
Okay. So now we're gonna calculate the concentration of the acid. So volume of NaCO3, that's gonna be it's gonna be 6. This is 5. So that's gonna be equal to sorry, 25 times 10 to the exponent 3 to the exponent -3 is the cubic meters. And the volume of HCl, that's gonna be 35 -3. Sorry. Then the concentration is still gonna be the same. It's gonna be let me just erase this. The concentration of NaC is still gonna be 0.1. I'm pretty sure they made you aware that concentration is in M, which is mole per per cubic decimeter. So this is basically the first 2 steps. I think we're gonna come back to solve this. Then I'm pretty sure we'll be done for the day. Is that fine? So basically, now that we have our concentration, we have our volume, we can determine the number of moles of NaCO3. So the number of moles is equal to the concentration multiplied by the volume. Sorry, multiplied by the volume, which is gonna be sorry, let me just take this call quick. Um, so basically, I just realized that the equation is not balanced. So I think the chemical formula for sodium carbonate, I think I got it wrong. So I'm just gonna search for it. The carbonate, because I think it's Na2CO3, but I wrote Na sorry. Yeah, so it's gonna, I'm sorry. So sodium carbonate, that's gonna be Na2CO3. So that means I'm gonna have to erase that and this. So I'm gonna put it